Hello, welcome to my channel. We have been solving this past papers. So right now I have this mathematics paper 4 for mechanics and we are doing May June 2024. Okay, so let's begin. Uh, we have this question number 1. A car starts from rest and accelerates at 2 meter per second square for 10 seconds. It then travels at a constant speed for 30 seconds. The car then uniformly deaccelerates. So, okay. Sketch a velocity time graph. So we have time in seconds on x-axis and velocity in meter per second in the y-axis direction. Okay, so at time zero, the speed was zero because car starts from rest. And for 10 seconds, it keeps going for a speed of 2 meter per second. So up till 10 seconds, the car speed keeps increasing linearly, right? And in 10 seconds, what will be the final speed? We know Vf equals Vi plus AT. Vi is 0. Acceleration is 2 meter per second. 10 times is 10 seconds. So it reaches 20 meter per second. Okay. It then travels at a constant speed for 30 seconds. The 30 plus 10 is 20, 30, 40. So of 30 seconds at 40 seconds. The speed is constant at 20 meter per second. And then it deaccelerates to rest over a period of 20 seconds. So this is 40 plus 20 is 60. So in this period, it deaccelerates and come to a rest. So this is the velocity time graph for the motion of the car. Okay, now the B part is find the total distance traveled by the car. You know the total distance, the area under the curve, right? So we can assume that there are two things. One is this rectangle, and if I put these two triangles together, it will become one triangle. So there is one triangle and one rectangle. So the total distance traveled, distance is the total area under the curve, and that area is going to be for the triangle we say half, and base is 10 plus 20, so it's 30, and height is 20. Okay, and for the rectangle it is 40 minus and is 30 times 20, so it is 300 plus 600, so this is total is 900 meter. Okay, so this was part B. I hope it's clear. Now question number 2. Uh, two forces of magnitude 20 and F. Okay, so this is a force of 20 Newton, and this force we do not know the magnitude, but it is F newtons. Okay, okay. Given that the resultant force has no component in the y direction. Okay, so if I resolve this vector in x component and y component, okay, take this off and this two components, then this component would be it's 20 and sine of 60 degree. Okay, and 60 degree sine is 300 by 2, so it's going to be 20 under root 3 by 2, so it will be 10 under root 3. And this component, it is going to be 20 times cos of 60 degree, and cos of 60 degree is 1 by 2, so this is going to be 10 Newton only. Okay, given that the resultant force, so I have two forces, let me draw them here again. So one is this force, oh sorry, I made it big angle, and one is this force. So the resultant is going to be something like this, depending upon the magnitude. So this is the resultant force, right? Now they said that given that the resultant force has no component in the y direction, so it has no component in the y direction, so it's all in x direction. Okay, okay. Anyway, so in if all component is in x direction, it means this vertical component cancels with this vertical downward component. Okay, it means this f is equal to this vertical component, which is 10 under the root 3. So many newtons. Okay, I hope it is clear. It will, if I take the value 3 root is 1.732, so this will become 17.32 Newton. Okay, so this was part A. Part B says given instead that F is 10 Newton, find the magnitude and direction of the resultant force. Okay, now this is a bit complicated. Not too complicated anyway. So we have two forces. One is vertical, something like this, and the other one is 10 Newton here. And the resultant is something like this. You know, we will know why I'm talking about this one. Anyway, so the resultant force, okay, resultant force an x component and y component. So what is the x component of the resultant force? It is equal to the x component of the of this force. So this is 10 Newton. So this is, we know it is 10 Newton only. Okay. Now, what is the y component of the resultant force? So y component in vertical direction, we have 10 under root 3. Remember? So this force has a vertical component of 10 under root 3 Newton. This is also 10 Newton. Okay, so the vertical component is 10 under root 3 and minus downward component is 10 Newton. Am I right? This is going to minus 10 Newton. Yes. So I can write it as 10 and under root 3 minus 1, so many newtons. Okay, so I need to find the resultant of these two forces. Okay, so the resultant force F is, by using Pythagoras theorem, Fx square plus Fy square. So this would be 100 plus, when I make the square of this thing, it will become 100 and under root 3 minus 1 square. Okay, I hope it's clear. So if I try to simplify, the 10 will be outside and inside I will have 1 plus the square of this. The 3 under square is 3 and minus 2 under 3 and plus 1. Okay, when I use the formula a plus b whole square and expand it, it will become like this. So it is 10 and under the root I have 3 plus 1 plus 1, 5 minus 2 under root 3. Okay, and this thing, if I try to find the exact value, it comes out to be 12.393. Okay, so this is the magnitude of the resultant force. Okay, and the angle theta is tangent inverse Fy over Fx. So it's tangent inverse, and Fy is this one, which is 10 and under root 3 minus 1 divided by Fx, which is 10. So it is tangent inverse under root 3 minus 1, and this thing comes out to be 36.21 degree. Okay, so my resultant force has this magnitude and at this angle. So it is something like this, that the angle is 36.21 and the magnitude is 12.39. Okay, so this was part B. Okay, so these are the two questions. I think I should stop over here and we can see we can do the other question in the next video. If these videos are helpful to you, then I will appreciate if you can subscribe my channel. Thank you very much for watching. See you in the next video.